Hi, welcome, and thank you for joining in. A quick tip before you go any further. All programs discussed in the videos have links in the description below. You can click and look at them and understand them better. And also don't forget to subscribe. Hi everyone, we start with building blocks of Python programming, and the topics we're going to cover are Python character set, tokens, keywords, identifiers, and literals, an introduction to the notion of a variable and the methods to manipulate it, concept of L and R value, data types, integer, float, and string, escape sequences in string, and comments in Python programs, along with operators, typecasting, input and output statements. Every programming language consists of syntax and semantics. The syntax of a computer language is the set of rules that defines a combination of keywords, data storing variables, operators, and other symbols that are considered to be correctly structured in that language. Now, to check the meaning given to a combination of the symbols, that's done by semantics. That means the logic should also be correct. Whenever we learn a new language, we first look at the alphabets, the words, the punctuations, the rules, the structure. Similarly, when we are looking at a programming language, we should know the character set, the rules of naming variables, the data types of the values or literals, the operators that can be used, and the structure of its statement. We start with the character set. Now, Python 3 supports Unicode coding standards. Therefore, it can process all possible characters: Roman letters A to Z, decimal digits 0 to 9, white space characters such as space, horizontal and vertical tab, return, and all the symbols, mathematical, logical, greater than, less than, equal to, hashtag. All these symbols are supported by Python. Next, we come to tokens. Every programming language has its set of tokens, which consist of keywords, identifiers or variables, literals, data types, and operators. Keywords are special words which are already defined in a programming language, and they have a special purpose. They cannot be used for anything else. And we have to use them exactly the way they are defined. An identifier is a name given to an entity such as a function, a class, or a variable, and this is what makes that entity unique. There are some rules, however. The identifier can be a combination of letters in lower or uppercase or digits 0 to 9. They can have an underscore. An identifier cannot start with a digit, and you cannot use a keyword as an identifier. Python does not allow punctuation characters or any special characters other than the underscore within the identifier, and it is also case sensitive. Any two identifiers with different cases will be considered as two unique entities. A literal is the value given to a variable. In Python, we do not declare variables in advance. So as soon as we assign a value to a variable, we basically start using it. The assignment is done using the equal to sign. We look at this with various examples. In Python, each variable name is associated with an address which can store any type of data or even an object. Now, suppose I have a variable x and it has value 300. Basically, x will be pointing at the memory address of 300. If I now change the value to 200, x will be pointing at the memory location which will store 200. We are now going to look at variables in Python through a program, and we'll use the website tutorialspoint.com. We start with the variable z, to which we assign a value 150, and we use the id function, which will return an integer that points to the memory location. Now, the ID of 150 and Z is exactly the same. Similarly, we have two variables X and Y, which we've assigned values 300 and 600. We see the output of the ID here, and that is two distinct numbers. But if we assign x to y, in that case, x and y should point to the same location. We use the ID again, and we see that now they have actually returned the same integer, which points to the same location. We will now do something that is impossible in math and breaks all the rules of math. But in programming, this is perfectly fine. We add the values of x and y and assign them back to x. So now the value of x will be 600. In Python, multiple assignment is also possible. That means you can take three variables and separate them using commas, which are also called delimiters, and put it equal to three values. Now, these three values will be assigned in the order in which the variables are written. So x is got the value 300, y gets the value 150, and z gets the value 600. We can confirm this using the ID function. We'll now look at L value and R value. The concept of a variable in Python is very different from the mathematical concept of a variable. In math, a variable's value is fixed and determined by the mathematical relation, whereas in Python, you can assign a value to a variable at a specific time, but later in the program, you could change that value as well. You can also manipulate the right-hand side in different ways and assign that same value to the left-hand side. This we will look at with an example. Now look at an example of L value and R value in Python. We'll also look at the arithmetic operators here. We start by assigning the value 5 to x. In the next statement, we increase the value of x by 5 and put it equal to x, which means we reassign the value to x. Now, if we output the value of x, it has become 10. We can also multiply the value of x by 5 and reassign it to x. Now, the value of 10 will be multiplied by 5 to give us 50. We can divide the value of this x by 5. We get the output 10.0. And the value of 10 can be raised to power 2, and we get the output 100. So in all these statements, we are making changes to the right-hand side. We evaluate the value of x and reassign it to a variable on the left-hand side. In this case, we've reassigned it to x. In programming, giving the value on the left-hand side and giving the variable on the right-hand side will give us an error. So here it gives a syntax error saying cannot assign to a literal. We can also not perform any operations on the left-hand side. It has to be done on the right-hand side. Otherwise, it gives us an error, can't assign to an operator. So this is how programming rules are different from mathematical rules, where the left-hand side is equal to the right-hand side. In programming, that is not how the equal to sign works. This is an assignment statement, and it has different rules. As seen earlier, literal is the raw data or value given to an identifier or variable, and its value depends on its usage and its data type. The data type of a literal can be a string, a numeric, Boolean, special literal none, or a literal collection, lists, tuples, or dictionaries. Let's look at an example. In this example, we are going to look at comments, strings, and escape sequences. Comments are small notes basically to describe our code, and they can improve the readability of your program. A comment can be single line or multi-line. Single line comments start with a hashtag. Multi-line are also called docstrings, and they're written within triple quotes. The quotes can be single quotes or double quotes. Single line comments can be written independently in a line, or they can be put at the end of a coding line. Let's look at the string data type. The string data type can have a variable which is assigned to any kind of text within quotes. The text could be numbers, special characters, alphabets, digits. It could be single line or multi-line strings. So multi-line strings are again written within triple quotes. They can also be written within single quotes and a backslash to end the line so that it's read as one line. We look at the output of these three strings, that is string 1, new string, and my string. And we see that the output gives the multi-lines as they are given in the formatting. We also have a string with escape characters. Backslash n stands for new line. Backslash with quotes will make sure that the string understands that this is actually quotations within the string. And backslash will make sure that the backslash remains as it is. We will be doing escape characters in detail in another chapter. We now look at numeric data type in Python through a program. We start with integers. Integers can be positive, negative, or 0. And in int, we have all the number systems, that is decimal, hexadecimal, octal, binary. And we have used an example of all of these. And with the function type, we can also see what is the data type of each of these. So in this case, all of them are int. However, if a number has a decimal point, it is a floating point number, which is another data type, and it's called float. Another numeric data type is complex numbers, and the symbol used is J, which is equivalent to the mathematical I for complex numbers. Here we've used two variables x and y to store two different complex numbers. We use a variable z to add these two and we output it. We get a number which is 10 plus 10j, and the class is complex, that is the data type here is complex. We now look at an example where we are going to look at three data types: Boolean, none, and collection. We start with the variable y to which we assign the value 0. We will check what is the Boolean value of y, that is, using a function bool, we output with a print statement bool y and it returns a false. If I put a variable z equal to 1 and then check its Boolean value, it will return true. So that means that if the value is 0, it's false, 1 is true, or anything other than 0 is true. If I take a string which has nothing within the quotes, it will return a Boolean false. However, even if I put a single space, it will return true. Now look at another data type called none. None basically stands for null or no value. If I pass none to the bool function, it will return false. Now we look at three data types within collection in Python. Tuples, which can be a set of values written within parentheses, lists, a set of values written within square brackets, and dictionaries are pairs of values written within curly brackets. So here we have an example of an empty tuple. If we use the Boolean to output this, it will give us false. If we put any value within the parentheses, the Boolean value of tuple 2 is true. List 1 is an empty list, so the Boolean value is false. If I put any string or numbers or anything inside the list, it will give me true. If I use a dictionary with pairs of values, it gives true. An empty dictionary will return false. We start with typecasting, conversion, or coercion in Python, and we start with implicit typecasting, where one data type will get converted to another data type on its own. So we've taken two integer variables, x 200, y 20. When we divide and output the result has changed into a float, that is 10.0. Similarly, if we add an integer and a float, or we find the difference between an integer and a float, we will get an output which is float. So this conversion is called implicit typecasting. However, we can also do explicit typecasting where we change one data type to another using constructor functions. So for example, if I write float of x, it changes the integer x to a float. If I say int z, it's going to convert this float z into an integer. Similarly, if I want to convert y to a string, I write str and in bracket give y. If I want to change a string to a float, that is also possible. A string to an int is also possible. We can also change Boolean to float and Boolean to int. Similarly, we can change a float and int to a Boolean. We can also change an integer to its binary equivalent number by writing bin and giving the integer. We can also change the binary number back to an integer using int. The complex numbers can be converted from integers by giving the first integer, comma, the second integer, which is the imaginary part, in the bracket and writing complex. Dynamic typecasting means that during the program, you can change the value of the variable to a different data type. For example, we take a variable val, give it a value 34, that is integer. And during the course of the program, we can actually say val is equal to my new value, which is a string. And this is perfectly legal. And you can do it in Python, that is change the data type whenever you want and declare it at that point. User input is an important part of Python programming, and it's done using input statements where we prompt the user to enter some information. It's done using a keyword input, and in the bracket is the prompt. Once the user gives the information, it is stored in a variable, which can later be used either to evaluate something else or simply output. By default, the user input is string in data type, but it can be explicitly typecast to change it into either an int or a float or any data type that you wish. Once we have the user input, it can be used in the program to evaluate other stuff. But it can also simply be output using a print statement. Print is our output statement. And once we use print in the bracket, we can give multiple variables. We can also make it more readable by giving some statements along with the variables. So input and output statements are going to be an integral part of the coming chapters, and we learn more about them as we go further. Before you go, don't forget to click on the links in the description below. They'll help you understand the programs better. Also subscribe to the channel, click on the bell icon so that every time I upload a new video, you'll know of it. See you soon. Bye-bye.